So in this video we are going to see about the device interface class. A device interface class is a way of exporting device and driver functionality to other system components, including other drivers as well as user mode applications. Drivers can register and enable the device interface for the created device object, and user mode application uses the generated symbolic ring to communicate with the device object. So up to now we have created the symbolic ring normally, but we are going to register the device interface class, and that function will generate an symbolic ring for us, and we will be using that to communicate with the device object. Device interface class is associated with the GUID, unique identifier. We can create our own class GUID. Some examples are GUID dev interface mouse for mouse interface class, and GUID dev interface disk for disk interface class. If you are writing a mouse or disk driver, you can register the device interface class of type GUID dev interface mouse and disk. We can create the GUID using the Visual Studio tools create GUID, and we need to import init GUID.h and wdm GUID.h to import this define GUID macro. So we can Google for the device interface classes. So the MSDN docs gives us good information. Any driver of physical, logical or virtual device to which user mode code can direct IO request must supply a name for its user mode clients. So far we have been using the normal symbolic ring, and starting with the Windows 2000, our drivers do not name device objects. Instead, they make use of device interfaces which are grouped by device interface class. So a device interface class is a way of exporting device and driver functionality to other system components, including other drivers as well as user mode applications, and we can register and enable the device interface instance of the device interface class. So each device interface class is associated with a GUID, and also one driver can register and enable multiple device interfaces for single device that they control. For example, a driver for a disk that can be mounted should register for both its disk interface class and mountable device class. And when the driver registers a device interface instance of a device interface class, the IO manager associates the device and the device interface class GUID with a symbolic ring name, and we need to enable the device interface in order for the symbolic ring to be usable for the driver or application to send IO to. And the registration of the link persists across the system starts, but the device interface must be enabled by the driver on every enumeration of the device. So this is the function. So let's move to the next slide. IO register device interface. We can use this function to create new instance of a device interface class. This function associates new instance with a PDO physical device object, so the instance can survive driver unloads. We can remove the symbolic ring from the user mode application as well. The function outputs and symbolic ring which can be used by the user mode applications to communicate with our device after we enable the device interface. Example for a GUID is this one. And during the disabling the device interface, if we disable inside IRPMN surprise remover, we should not disable in the IRPMN remove device. We will see this later in this video. So this is the function signature. So we need to pass the PDO for the device because the device interface instance will be tied to the physical device object. So our function device object can be loaded and unloaded, but the PDO remains constant. So that's why the device interface instance will be associated with the PDO. And the second parameter is the interface class GUID that we have just seen. And the next one is the reference string. We can pass null The function drivers specifies null, filter drivers also specify null, and the symbolic link name. So this is the output parameter. The function writes the contents to this variable, and we need to call the RTL free unit Unicode string when it is no longer needed, because the function allocates some memory for this Unicode string. And the function returns status success if the call was successful. And one more important note is it returns status object name exists if it is already registered. So that's why we need to handle this result as well. And the next one is enabling. This is the function syntax for the IO register device interface. And the next one is IO set device interface state. So after creating the device interface, we are just going to enable or disable. So the function syntax is very simple. Pass in the symbolic link name, and the second parameter is a boolean value, true or false. True for enabled, false for disabled. And it can also return the status object name exists. So inside our definitions, we are going to create Unicode string, symbolic link name, and the boolean value is device interface enabled. So here is one important note. If the driver calls the IO set device interface state to disable a device interface instance in response to an IRPMN surprise removal, the driver must not attempt to disable the same device interface instance in a response to IRPMN removal remove device IRP. So that is why we are tracking the state. If it is disabled already when you receive the IRPMN remove device, we should not disable that again. So okay, we have declared the Unicode string and the boolean value. So inside the add device, we are creating the device, and if it is not success, we are returning error. And then we are attaching the device to the PDO device tag. And then now what we are going to do is we are going to so first you can go to the Visual Studio tools and create GUID, and you can select the second option and you can click on new GUID and then copy. So click on copy and you can paste that in the add device.h. So I have already created this one. I just pasted this. So here you can change the GUID name. So I have put this as GUID dev interface my device 2. So let's call the IO register device interface. So the first parameter is the pointer to PDO, and the second one is address to GUID dev interface my device 2, and the reference string is null, and the last one is pointer to Unicode string. So we have already declared a Unicode string structure in our device extension. We have already created the device object and attached it to the PDO. So we have already PDE the device extension. So I am going to pass the address of PDE symbolic link name, and we are going to receive the NT status. So if res is equals to first we are going to handle the status object name. Already a name exists, status object name exists. So we are going to print device interface already exists. And we are going to print the symbolic link name. %w capital Z to print the Unicode string structure and pass in the PDE symbolic ring name. Else if NT success of res, so that means the device interface has been registered successfully. So copy this, paste here, and device interface registered successfully, and we are printing the symbolic ring name. Otherwise the function has been failed. What we are going to do is we are going to detach the device and delete the device. So IO detach device, we can just print first device registration failed and print the result value, and then IO detach device, detach from the lower device object, and then IO delete device, pass in the device object, and then return result value. So we are undoing what we have done so far. So here after we can set the PDE is device interface enabled is equals to false, because at this point we have just registered the device interface. We have set this to false, and inside the start device, so this is the start device, we pass down the IRP and wait for all the lower devices to complete the IRP, and if the IRP has been successful, then we are going to set the device interface state. So IO set device interface state, IO set device interface state, pass in the PDE symbolic ring name and the boolean value true, and this also returns the NT status. We need to handle the status object name exists. If that was already enabled, so result is equals to, so if res is equals to status object name exists, device interface already enabled, else if NT success of res and device interface enabled successfully. And also we are going to modify the is device interface enabled to true, otherwise the function has been failed. So setting this to false, so device interface enabling failed, and then what we are going to do is we are going to fail this IRP. IRP means start device, so IRP IO status dot status is equals to result, and IO complete request IRP and return a result value. So this we can print here. So this is enabling the device interface state, enabling the device interface state. And inside the stop device, if the device has been stopped, we need to disable the IO device interface state. So this is similar to removing the symbolic link, so that the user mode applications will not access our device object. So what we can do is, we can just copy this code and paste it here and change this to false. Change this to disable. Otherwise we can print the disabling failed. So we can copy this one and paste it in surprise removal. And also here inside the IRP remove device, we need to check if PDE is device interface enabled is equals to true. Then that means is equals to false. Then that means device interface disabled already, probably by IRP surprise removal. Otherwise again paste this code, we are disabling the device interface state. And if everything went smooth, we can free the Unicode string PDE symbolic link name. So that is what the paragraph says. So I think we are good to go. I have already installed the driver just before recording of this video, and I am using the normal IO create device, not the device secure, for testing purposes. So I have already installed the software PNP power driver. So devcon remove root software pnp power. Now we are going to install the driver. Now we should see the device interface. And you can see the symbolic link name. So registering the device interface class, registered device interface successfully, and symbolic link name. So this you can see the GUID, that is the GUID we have passed to the IO registered device interface function. Here this one, so you can see the values ending with CE 6 CE. So what you can do is you can try to copy and paste here. So copy this exact symbolic link and you can just paste it here. So let's run our application. Now we should open the handle to this symbolic link. Enter the process ID 5952. And you can see we got the hello there from driver, and also the notepad has been killed successfully. So this is how we can register the device interface and enable the device interface state so that the user mode applications can access our driver. So that's all for this video, and thank you for watching.